to my 5-part video series on surds. In this first video we're going to talk about what a surd actually is, so naturally it'll be a fairly short video. So a surd is a square root that's also irrational. So an example of a surd would be the square root of 5, but the square root of 4 would not be an example of a surd because it can be simplified to 2, which is not irrational. So let's have a look at, first of all, the number system. I'm going to introduce some basic concepts around the number system to you that if you do specialist maths, you'll see more of. So first of all, I've got a diagram here I'm going to build up the number system in. Inside this circle here, we have what's called the natural numbers, often denoted by an N with a double stroke in the middle. And the natural numbers are all our counting numbers, such as 1 and 3 and 7, for example. The next circle is the whole numbers. So I'm just going to write down whole. And the whole numbers are the natural numbers, but with the addition of the number 0. And the next circle, we have the integers. And the integers are denoted with a Z with a double stroke, and integers include the negative numbers as well. But still, you'll notice that they're all whole numbers. And then outside of that, we have what's called the rationals, often written as a Q with a double stroke there. And the rationals are any number that can be written as a fraction. So all of these whole and integer numbers, they are rational numbers because, for example, 2 can be written as 2 over 1. But this also includes other common fractions, such as 1/5, so 0.2, or 1/3, which is not a rational but does have a recurring decimal, 0.33 recurring, or even something like 578 over 2. So obviously fractions can be larger than 1 or less than -1. So there's some rationals for you. And then outside of the box, just in that little bit that's left over, we have the irrationals. So these are the irrational numbers that don't fit in with the rational numbers, but they're still numbers. So for example, pi is one of those common ones. 3.14159 goes on forever, never repeats. And then we also have the surds. So root 2, root 5, root 7, or root 8, for example, plus many others. So the square root of any whole number that can't be simplified to a rational number is a surd. Now this is the group of real numbers, and I just want to bring your attention. I don't want to lie to you, but moving forward, if you do specialist maths, you'll realize, or you'll notice and you'll learn that there are numbers beyond the real numbers, but for now that doesn't matter too much. So let's have a look at a quick example. Let's imagine we had these numbers: 2, 3 over 4, root 2, 2 root 9, which means 2 times root 9, and 1 plus root 3. I've put in here some common representations of surds, and you'll notice here that the surds, in this case, 2 is not a surd, 3 over 4 is not a surd, so 2 is a natural number. 3 over 4 is a rational number, but not an integer. Root 2 is a surd, it doesn't simplify. And 1 plus root 3 is a surd. The 1 is a natural number, but the root 3 is a surd, so therefore the addition of those two is also a surd. But the other number there, 2 root 9, is equal to 2 times root 9, which is 3. That's actually equal to 6. So this is another example of a natural number. So there you have it. That's what a surd is, and we'll be dealing with the arithmetic of surd, doing the distributive law over surds, and something called rationalising denominator in further videos. All the best.